Hello everyone, welcome to your 5-3 lesson on step functions. Our learning target for today, we are going to be able to graph and apply step functions. We'll graph step functions including the ceiling functions and floor functions, and we'll be able to calculate and interpret the average rate of change of step functions. So, what are we talking about, right? What is a step function? A step function is a piecewise defined function that consists of constant pieces. So what we mean by constant, if you have a constant function, that's a horizontal line. So we're talking about horizontal lines. The graph resembles a set of steps. And so when we look at this in the next video, you'll see it kind of looks like stair steps, just the horizontal parts of those steps. The ceiling function is a type of a step function. So it's going to have those constant pieces, the horizontal lines, but it rounds numbers up to the nearest integer. So it's called a ceiling function because it rounds numbers up to the ceiling. There's two ways to write this. F of x equals, you might see it written out in words, ceiling applied to your x term. Or more commonly, I think you're going to see f of x equals, so here's our x. It looks like a bracket, but only has the top part of the bracket right here. And so that says take your x value and round it up to the nearest integer. So for example, what we're talking about is, let's say we had f of 2.1. Well, if you apply a ceiling function to 2.1, it's going to round 2.1 up to the nearest integer, which will be 3. So the ceiling function of a value of 2.1 rounds up, giving us a value of 3. So a floor function is another type of step function. In this case, though, it rounds numbers down to the nearest integer. So it rounds it down to the floor. Notation is pretty similar. F of x equals, we could say floor of x, so apply the floor function to x. Or you could have your x value, and then your bracket is going to include the bottom part of the bracket right there. Just those little, it's real small detail, but that makes a difference on if you're going to round this x up or round the x down. So an example of that, let's say, well, let's just use that same f of 2.1. Well, if it's a floor function, I want to make a bracket. I have to remember only the bottom part. So it's going to round 2.1 down to the nearest integer. So then the floor function would have a value of 2.